Chapter 19 is about confidence intervals, which we'll talk about in a second. We're focusing on proportions. So all the scenarios we'll be given are going to be dealing with proportions. So I know in chapter 18, you had to keep track of proportions and means and what to do with each one of those. But for the next few chapters, we'll just be dealing with proportions. I told you at the beginning of chapter 18 that this semester things get quite repetitive, and I wasn't lying. So we're going to talk about confidence intervals when you have a proportion. Then we're going to talk about hypothesis tests when you have a proportion. Then we're going to talk about confidence intervals and hypothesis tests for when you have two proportions. And then for when you have a mean. And then for when you have two means. And we have paired tests. All right, so for now, it's going to split everything up for you so I can explain the general mechanics and everything. So we'll do confidence intervals by itself in chapter 19. And then we'll do hypothesis testing in chapter 20 all by itself. But then in later chapters, it starts lumping them all together because the general ideas are the same. Okay? So chapter 19, just about confidence intervals. In order to do some things in chapter 19, you have to know the things from chapter 18. So you had to keep track of two separate things in chapter 18. You had to know what was happening in the population. So you got a population proportion, P. And then you had to know what was going on in your sample. We had a sample proportion, P hat. You have two different proportions in chapter 18. Then we wanted to see what we needed some sort of model. We wanted to see what was going on. And so we used a sampling distribution model, which was a normal model, with a mean of whatever P, the true population proportion was, and a standard deviation of the square root of PQ over N, which was on the AP formula sheet. All that stuff we've learned already. We're going to have to use sampling distribution models in this chapter. Remember, they're completely theoretical. They aren't real models of anything. Like for the M&Ms, we can't actually physically go and take 50, sample the size 50 over and 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 over again. You can't do it. It's not practical or feasible. So it's completely theoretical. Okay? So all that stuff is going to come back to haunt you, including the conditions. Because if you're going to use a sampling distribution model, you have to be able to check your conditions as well. Right? So you check to see if the samples are independent of each other, and you say that by checking if it's random or not. But it doesn't tell you it's a random sample. You decide if it's a good representation of the population or not. You check to see that your sample size is less than 10%. And then for sample size, since we're dealing just with proportions in this chapter, you look for success failure. Number of expected successes is greater than or equal to 10, and the number of expected failures are greater than or equal to 10. Anything having to do with means is not important to you in this chapter. Okay? We'll come back to means chapter 23. Okay? So everything we're doing with right now is proportions. With that being said, I'm going to talk you through the concept behind a confidence interval today. We're not actually computing any or doing anything. We're just going to be talking about what you can and can't say, what it all means. We'll actually compute things tomorrow. And the book uses a really good example, so I'm going to give you the context of that example, so we can talk about it. All right? So, in chapter 19, the textbook authors decided to talk about coral. Right? They're looking for the proportion of sea fans, which is a type of coral, that are infected with some disease. All right? So they have some researcher goes down to this reef, and they sample 104 of these sea fans to figure out what percentage are infected. All right? That's the background of what I'm talking about. Okay? All right. So the researcher goes down there, samples 104 sea fans, finds that 54 of them are infected with this disease. So that means we have a sample proportion of 51.9%. Okay? Now, if every single one of you in this room went down to the same reef, took a sample of 104 sea fans, you all wouldn't come back up with a 51.9% proportion that are infected, would you? No, we've talked about that millions of times in this class. So we know that there is a certain level of sampling variability. Okay? We don't know if your particular sample is close to the actual population proportion or not. We have no idea. Right? No clue. Okay? So, we need to start thinking about, well, how close really is it to P or not. We need to think about that. And so the best way to do that is to get lots of samples of size 104. And we know we're not going to practically go and take millions of samples of 104. We're going to imagine that happening. So we're going to use sampling distribution models from chapter 18. Okay? So we need to build this model. Now, in order to build the model, you need a population proportion so you can find the mean and standard deviation. Is there any feasible way to figure out the percent of infected sea fans total on a huge reef? Probably not. So is there any way for you to know the true population proportion of what's infected? Not really. So in this scenario, we don't know what P is. That's a problem for what we did in chapter 18. Right? We have no way of knowing, again, unless you went down there, I mean, you had to go down there a specific day, because then conditions can change and disease can spread, whatever. You have to go down on a very specific day, count every single sea fan in this huge coral reef, and figure out how many of them were infected. And if you've ever been scuba diving, you can't stay down that long. All right? So there's just not a way we're going to be able to figure this out. We're going to have to do lots of estimating then. All right? So we don't know P, but we do have a P hat. We do have a sample proportion. So I could create a model, but I have to estimate. So I could find the standard deviation, but I'd have to estimate because I don't have P and Q. But I do have a P hat and a Q hat. So that's what we're going to start doing. We're going to start all this model business. We're going to start by just estimating because we have no other way of knowing. A confidence interval is always going to be based on some sort of estimate. Always. Because there is no way of knowing what P is. So when you estimate the standard deviation, since you're estimating, we call that the standard error. That's going to come up a lot of questions, a lot of problems. So when it asks you about the standard error, you need to understand it's just the estimated standard deviation. It's a fancy name. Okay? But know what that is. In order to find the standard error, we use the same exact formula that we have from chapter 18. We just don't have P and Q, so we have P hat and Q hat. We do have a sample size. We know that they, in this particular scenario, they went and sampled 104 sea fans, so I do have an N. But again, I don't have P or Q, so I have to use P hat and Q hat. So this formula, not on the AP formula sheet, as written right here. But the standard deviation for our sample proportion is still on there. It's the square root of P, Q over N. So you just need to know, oh yeah, when I'm doing confidence intervals, I estimate instead. Everyone clear so far? Well, then I could start building a model. If I knew what P was, then I could start doing plus or minus the standard error in a normal model. So from the example in the book here, they calculated the standard error. It's 4.9%. And if I knew what P was, I could start adding that 4.9% as my standard deviations in my model, right? I know that 68% is within one standard deviation of my data is within one standard deviation, right? 95% is within 2. Okay? So some things you could talk about from this sampling model is, you know that 95% of random samples would be no more than 2 standard error away from P. If we knew what P was, that would be true, right? If you were P hat then, because our P hat, we actually know what that number is. There's a 95% chance that P is no more than 2 standard deviations away from that. So if we think about estimating, and we replace P with P hat, because we have to have some center, so we are estimating it by using our sample proportion. But there's a 95% chance that the actual population proportion is within 2 standard errors. That's the whole entire point of a confidence interval. We do not know P, but we can create an interval using all of our estimates with our sample proportion that we could try to trap P. Okay? So that's the whole entire point. We will never know if we actually do, because if we knew we could trap P, then we would know what P is. Right? So the entire point of the interval is you create this interval of values from blank percent to blank percent, and we, with some level of confidence, can say that the true population proportion falls within that. That's the idea, okay? So if we use p hat as a center, and we have our standard errors, in this case we used 2, and it was 2 because we had that 68, 95, 99.7 rule, right? Those are distinct cutoffs for us. Then we can say with 95% confidence that p is somewhere in our interval. Maybe. Right? There's 5% chance it's not. So 95% confident that p is somewhere in the interval. There's a lot of things you can try to say then that are incorrect. Right? So what I'm going to do is go through a bunch of statements that you might come up with, say, about a confidence interval that are incorrect. Then we'll get into what's actually correct and what's the best way to write something. Because again, we're talking about the concept. Does everyone understand, though, that if we use our sample proportion to be the center and our sample proportion to calculate the standard deviations, that we can try to trap p in some sort of interval? Because that's the idea we're working with today. All right. So here are some things you can't say. 51.9%, which was just their sample proportion, of all sea fans on this reef are infected. Do we know that 51.9% of every single sea fan on the reef is infected? No. You know 51.9% of the sample you took is infected. So be careful what you say. Make sure you're talking about specific populations. Your sample, the actual population, what are you actually referring to? Second one. It is probably true that 51.9% of all sea fans on the reef are infected. That's a little bit more wiggly than the first statement, but is it probably true that that exact percentage is infected? No. Again, that was from your sample. We have sampling variability, right? So that could have just been one sample. We don't know. So it's probably not, it's not necessarily probably true. We don't know exactly what proportion of sea fans on the reef is infected. That's a good clause to start with because that's true. We don't actually know. But we know that it's within the interval 51.9% plus or minus 2 times 4.9%. That is, it's between 42.1% and 61.7. So that's the actual interval. You took p hat and you added 2 standard errors and subtracted 2 standard errors. You got an actual percentage. So do you know that p is within that interval? No. We're 95% confident that it is. That means there's 5% chance that it's not. So you do not know that p is in that interval. Be careful with that. Okay, here's something we could say. And it's true. This sounds pretty bad. We don't know exactly what proportion of sea fans on the reef is infected. But the interval from 42.1% to 61.7% probably contains the true proportion. That's true. We don't know where p falls, but it probably falls in the interval because we're 95% confident. But we've made a wishy-washy statement, and it's wishy-washy in 2 different places. It's wishy-washy because we already said we don't actually know. And it's wishy-washy because we said it's probably in the interval. So if you're writing a research paper, and you do a confidence interval, this would be a terrible conclusion, right? They would be like, really? That's all they got, okay? It doesn't show that it's backed up with any statistics or that's backed up with any sort of anything. It just says, oh, it's probably in there, blah. It doesn't really explain much, okay? So when we are talking about confidence intervals, you are always going to use the same template. We are blank % confident that. So you always start with how confident you are. You don't have to be 95% confident. You can pick whatever percentage level you want to. Okay? Now, you can use 95. You could use 99.7 because you know the model. But that's not the only thing you can use. You can use 98%. You can use 99%. You could use 72%. You could do whatever percentage you want. But let's think about some things. If you were 100% confident, what would your interval be? If you're 100% confident that you're going to trap p, what would your interval have to be? 0% to 100%. Right? If you're 100% confident, then you have to include every possible value for P, right? Well, that doesn't sound very good. That just means you're guessing. Okay, so even though 100% confident sounds better, it's not. Okay, so let's not go there. Same thing when you get to be less confident. If you're only 50% confident, that's not very confident. So what's the point? Again, it kind of seems like you're not trying, okay? So, again, you can use whatever confidence level you want, but generally speaking, you're going to see confidence levels from 90 to 98, okay? Because those seem to make sense, right? You're at least trying at that point to trap P, okay? So you'll see again 90 to 98%. Anyway, you say we are blank % confident that between, you give an interval of the whatever you're talking about, or whatever, okay? So same context every time. We're 95% confident that between this % and this % of the C fans are infected. It's a very straightforward statement, and every single time you should say the same thing. In this class, for the rest of the year, when I tell you to write something a specific way, I'm not telling you that as a suggestion. Because when I tell you as a suggestion, then you go off and like freelance your own crap, and then it doesn't sound good. You end up saying something you really didn't mean to say. You end up saying one of these things over here that you really didn't mean to say, and you know are wrong, but it sounded good at the time. All right, so not a suggestion. Whenever we're talking about a confidence interval, we say we are blank % confident that between blank % and blank % of whatever is happening. Okay? Now, there are a bunch of different confidence intervals that are calculated a bunch of different ways. That's going to be the problem in this class. Right now, we're only going to have one. It's not going to be an issue. By the time we get done with chapter 27, you'll have 1, 2, 3, 4, 5, 6 different confidence intervals you have to know. They all have a different name. You have to be able to name them. So this one is a 1 proportion because we're dealing with 1 proportion. Z indicates like you're using a z-score idea, which indicates you're using a normal model. So Z interval. It's not that super hard to remember, but I'm just saying at the end of this, we're going to have 6 of them. You have to know which one's which. So 1 proportion Z interval is what we're talking about. Again, we'll calculate them tomorrow. Everyone comfortable with the concept of we're trying to trap P? Okay. So let's do this just checking together. We're going to look and see if these statements are correct or incorrect. A Pew Research study regarding cell phones asked questions about cell phone experience. One growing concern is unsolicited advertising in the form of text messages. Pew asked cell phone owners, have you ever received unsolicited text messages on your cell phone from advertisers? And 17% reported that they had. Pew estimates a 95% confidence interval to be 0.17 plus or minus 0.04, or between 13% and 21%, right? So we know some information. So they're going to give us 5 statements. We decide if they are correct or not. If they're incorrect, we need to say why. Number 1, in Pew's sample, somewhere between 13% and 21% of respondents reported that they had received unsolicited advertising text messages. Questions, is this true or false? It's technically true, but yes, they're talking about the sample, and we know that 17% got unsolicited advertising text messages in the sample, right? So the statement itself is technically true because, yes, somewhere between 13% and 21%, but we know the exact number, so that's kind of a dumb statement to have. It's true, like but it's kind of dumb. It's, you know the number. Yeah, there's like a better answer. You could say in the sample 17% got these messages. Right, they're just talking about the sample in this case. They're talking about the sample, we already know about the sample. So the statement itself is technically true, but we could do better. On 2, we can be 95% confident that 17% of U.S. cell phone owners have received unsolicited advertising text messages. Right, that's false. We're 95% confident that the number of people falls in the interval, right?
Right.
Not that it is that specific number. Yeah. On 3, we are 95% confident that between 13% and 21% of all U.S. cell phone owners have received unsolicited advertising text messages.
Wait, no, because it says all U.S., not teens, right? Or did it say teens or something?
You made that up.
Okay.
That's correct. Now, if the sample had been just about teens in the U.S., if it was about just teens in the U.S., then you wanted to say teens in the U.S., and that's true. But you made that up in your brain. This is just about U.S. cell phone owners. I don't know where you got that. But so, yes, this is correct. All right. And it gives a confidence level. It gives the interval. And it tells about the population you're dealing with, not the sample. Okay? On 4, we know that between 13% and 21% of all U.S. cell phone owners have received unsolicited advertising text messages.
No, we don't know that.
We don't know that. We're only a little bit confident, 95% confident, and that's based on one sample, so not every single person, like not everybody is going to maybe be 17% or between that. We don't know. This was a bad word to use. 5, 95% of all U.S. cell phone owners have received unsolicited ad text messages. That's just way wrong. That's just not even close. Right, right. No, but yeah, so that doesn't have anything to do with anything, right? We're 95% confident. It has nothing to do with 95% of people. Okay. Now, you need to understand this as well. This is going to come up in multiple choice questions all the time, so you might want to write this down. What does 95% confidence really mean? It means that 95% of samples of this size will produce confidence intervals that capture the true proportion. So out of all the possible samples you could ever take, if you made a confidence interval for every single one of them, so we made a confidence interval for every single sample in our sampling distribution model, 95% of those confidence intervals would capture P. That's what that means. So let's say, we'll go to the C fans for a second. Every single one of you, I send you all down to the reef. You all take a sample to size 104, and you all come back up with your sample proportion p hat, right? And then let's say we've gone through tomorrow, and you know how to calculate your interval, okay? Then all of your intervals are going to be different, probably, right? If all of your samples are different, then your intervals are going to be different because it's based on different numbers, right? Okay, so in this picture, we're going to pretend we actually know the P. We're going to pretend we know P. We know the true proportion of C fans that are infected. These little dots would be your samples proportions, like your P hats. Okay? And then the bars would show your plus or minus standard error. Okay? It shows your interval. Now, again, if all of your P hats are different, then all of your intervals are going to be different. We only expect 95% of the intervals then to actually trap P. So if you start looking at this interval right here doesn't trap P, right? Doesn't get the green bar. This interval right here doesn't trap P. This interval right here doesn't trap P. Okay? That's why we can't be 100% confident, because we're not always going to trap it. Plus, we don't actually know what it is. Okay, so keep in mind, even if you do a sample and you do a confidence interval, you may not have gotten P. That's why we're only 95% confident. Did your confidence interval work? There's no way to know. If we do not know P, you won't know if you actually trap it or not. So you just go with it. You get the confidence interval, you go with it. All right? Questions? Then one more vocabulary piece. When you do plus or minus, that standard error part, okay, we call that the margin of error. That's the interval on either side of p hat. So when you do plus or minus, however many standard errors we're going to go, we call that the margin of error. Tomorrow I'm going to give you a formula for figuring out the margin of error. Because again, you don't have to be 95% confident. So I'm going to give you a formula so you can say whatever you want, however confident you want to be. Now, let's talk about this for a second. We were 95% confident earlier, right? We were 2 standard errors away from the mean. Yes? Let's say we want to be more confident. We had the 68, 95, 99.7 rule, right? Let's say I want to be 99.7% confident. So that is more confident. If you're going to be more confident, then what's going to happen to your interval? Is it going to get smaller or wider? It's going to get wider, right? 99.7 is 3 standard deviations or 3 standard errors away from the mean. So this is important. The more confident you are, the wider your interval is. We already talked about that 100% would be 0 to 100. Does that make sense? But the more confident you are, the wider your interval gets. If you start giving these really wide intervals, well, that's not saying much. Again, on the flip side, we talked about this earlier. If you give these really narrow intervals, then you're probably not very confident about it. Okay? But so just know, the more confident you are, the wider your interval gets. That's important. That's the type of question they ask on the AP exam. We change our interval, we change our decision, we're going to be 98% confident, so 95% confident. What happens to the interval? Okay, and I'll give you a bunch of choices. All right. I am not going to do all these questions. I just want to talk about them in general, and I'm going to give you 4 to do for homework. Number 1. So the TV newscaster reports the results of a poll of voters and then says the margin of error is plus or minus 4%. Explain what that means. Well, that means that the true proportion, P, of voters, that we don't know what they voted for, I don't know what the right, of voters, is within 4% sample proportion with some level of confidence. They don't really tell us any information. They don't really give us what confidence level they are using, doesn't give us any sample proportion, doesn't give us anything. So the best we can say is that we think that P is within 4% of P hat with some level of confidence. If they told us they were 95% confident, I'd be able to say that with 95% confidence, P is within 4% of our sample. But they don't tell us that. So this is the best I can do. That's what a margin of error means. All right. Number 3. It says for each situation described below, identify the population and the sample, explain what P and P hat represent, and tell whether the methods of this chapter can be used to create a confidence interval. You need to identify the population that they're talking about and the sample that they're talking about. Then you need to check the conditions. If you're going to base this all on an estimated sampling distribution model, then you have to check your conditions first. That's why I told you in chapter 18 that they weren't going away. Because tomorrow when we calculate stuff to actually make an interval for chapter 19, the first thing you have to do is check the conditions. All right? They're not going away. So, I will not go through this. I feel like you know the conditions. But that's what it's asking you to do. Check the conditions. If one of them is not met, then you're done for. So if you check the randomization condition and it's done via like internet poll, well, that's not a good sampling strategy, and that's biased, so it's not random. So then, no, you couldn't check any other conditions. Doesn't matter because you can't use Chapter 18 stuff, so then you can't actually do Chapter 19 stuff. Right? If one fails, they all fail. Okay. So make sure this is more practice with that. Number 5 is like what we did with the just checking. So there's going to be one on the homework where you go through and identify if the statements are true or not. I will tell you on the one I give you, there's only one statement that is true out of 5. All right, so actually think about them. Make sure that you actually read through them very carefully. They'll get you with one word, right? All right, then number 7 here, I want to talk about this one. Again, this is the type of question they ask you in the AP exam on the multiple choice. On the free response, they ask you to go through and actually create confidence intervals and all that jazz. But the multiple choice, generally, either they give you the interval and ask you a question, or they ask you something about intervals, and they ask you about concepts in general. So it might say, okay, if we do this, then what happens to this? And you're expected to know. So here are 3 examples. Which statements are true? So A. For a given sample size, that means N is staying the same. Higher confidence means a smaller margin of error. Is that true or false? False. The more confident you get, the wider your interval gets. That means your margin of error had to be larger. Yeah, it's the plus or minus part. Okay, so yes, this is false. Again, the more confident you are, the wider your interval is. If your interval is wider, that means the margin of error had to be larger. Okay. On B, for a specified confidence level. So let's just say, we're just talking about 95%. That's not changing. 95% confidence. Larger samples provide smaller margins of error. We talked about this a bit in Chapter 18. As your sample size increases, what happens to your variability or your standard deviation? It decreases, right? As your sample size increases, you're getting closer to the population size, as fractional as that may be. The larger your sample size gets, the closer you get to the population. So you're getting closer to P. Should be, right? So that means your standard deviation is getting smaller. So if your standard deviation is getting smaller, that means your margin of error is getting smaller. Because the margin of error is based on the standard error, or the standard deviation. Right? So that is true. Right. Yes. And then C, for a fixed margin of error. So let's say that we're saying what we're doing is plus or minus 4%, right? Larger samples provide greater confidence. So if you stick the margin of error, we'll see this more tomorrow with the formula, so I just want to see if you can think through it now. If you stick the margin of error at plus or minus 4%, that's what it's going to be. Larger samples provide greater confidence. We just talked about as the sample size increases, your variability decreases, right? So that means that the larger the sample, if your margin of error is staying the same, then you are getting more confident. Right? You're getting closer to what's happening in the actual population. So you are getting more confident about what's happening. If that doesn't make as much sense, tomorrow when we do the formulas for margin of error and stuff, I'll show it to you. Okay? Questions about any of these, though? All right, so I'm going to give you 4 questions. You don't need a calculator because you're not actually calculating anything. You're just talking about confidence interval in general. So on page 455, we're going to do 2, 4A and D, 6, and 8, A, B, C. I'm going to pass out your quizzes and we're going to go over them. So, Clay and Min, if you want to work on your homework in the hallway, you can.